So far, we are able to delete a head node, a tail node, and a node at any particular index. For this video, I want to create a function that will delete the whole list. In short, it's basically our garbage collection, or us cleaning our heap. Unlike the stack, where variables and other memory are deleted once it is popped off, the heap does not pop off memory that we've created inside of it, like our nodes or our linked lists. Therefore, we have to clean them up ourselves. Otherwise, they'll just stay there and become memory that's using our heap that can cause a heap overflow if we continue to use our heap and never delete anything. So for this video, I want to create a function that will delete our heap. Let me first create a function prototype, and it's going to be a node type. And we're going to call our function pop list, and we're going to use call by address, and we're going to set head as the parameter. So I'm going to copy this function prototype and create a definition for it at the bottom. Before I code the definition, on the right hand side is a pictorial representation of what I currently have in the heap. In main, calling our functions, both return by address and call by address, I've created a linked list that is incremented by 10. So as you can see, 10, 20, 30, 40, and 50. And we have 5 nodes total. I also went ahead and created an activation record on our stack for main. And main currently has a head pointing to null. Now once we call these functions, head will no longer be pointing to null. It'll be pointing to the first node of our list. I just noticed that I made a mistake here. It's not a pointer, so let me delete that from our function prototype and from our function. It's going to be a call by address. So now let's talk about the logic. And similar to our pop tail function, we are going to need to traverse through each node. And as we traverse through them, we want to delete the node before that. So basically, this is how we're going to do it. So I'll have a current node and a temp node, and they'll be pointing at the head node. So what I want to do is I want to traverse the current node. And as I traverse the current node, I want to free the temp node. So I want to free this. And then I want our temp node to follow. And then I want to traverse our current node again. And then I want to free the temp node. And we want to do that until we reach the end of the list. I went ahead and created a pop list activation record, although we haven't called it yet. But when we do call the pop list function, this is what our activation record in the stack frame will look like. So let me go ahead and code what we have here. So right here, I have a head pointer that's holding the address of our head in our main function. So what I want to do is I want to create a temp pointer, and we want to set that to head. And this is going to be a node data type. I also want to create a current pointer and also set that to head. Let me also go ahead and create an integer I to keep track of our index. On our activation record, we're going to have I as an integer variable. So the first condition that we want to target is if our list is empty. And how do we know that our list is empty? Well, if our head pointer is pointing to null, then we know our list is empty. So in that situation, all we want to do is we want to print F the list, or there is no list to delete, and then we're just going to exit 0. So let's test this condition. So in our main function, I went ahead and deleted all of our function calls. Therefore, we should have an empty list. And I'm going to call our function below our print list function. So we're just going to say pop list, and we're simply going to pass it the address of head. Let's run it. I misspelled it. So let's run it. The list is empty. Number of nodes, 0. There is no list to delete. Let me go ahead and add a print statement before that. So that way we'll be able to differentiate our prior list to when we delete them. So here I'm just going to put a print statement, print F, and I'm just going to put before garbage collection. And then I'm going to put 2 new lines. So I'm going to print that. There it is. So number of nodes before garbage collection. The list was already empty and there's no node to the list. I'm also going to put a new line here. So now we can tell. Our next condition is if our list has at least one node or one or more nodes. And if that's the case, we're just going to use else. And here we are going to use a while statement because this is where we want our temp to follow our current. Currently, our temp and our head pointers, they are pointing at our head node or the first node of the list. All we want to say is while current does not equal null, so we want to traverse current until it equals null. So that way we would know that we have come to the end of the list. Our condition is while current does not equal null. As we traverse current to the next node, we want temp to follow. Here we want to assign current to temp. And right now, current is assigned to temp because they are both pointing at head. But once we traverse to the next node, then we want temp to follow. Let me keep coding and illustrate that. So current, this is where we traverse current by setting it to current arrow next. Our current traverses to the next node and it's now holding the address of 0x100. As we traverse to the next node, you notice how temp is pointing at the node prior to the current. And if that's the case, we can free index 0. So we just want to free temp. But before I free temp, let me go ahead and do a print statement. And I'm just going to copy and paste the print statement from our pop tail function. I want this function to print out what node is being popped or deleted. Before temp is deleted, it's going to print out what it is pointing to. Now it goes back to the while condition on line 68. Does current not equal null? Well, let's take a look at current. No, it's not equal null. And by this time, this has already been popped off. So if that's the case, we're going to set the address of current into temp. So temp is going to follow current. And on line 71, current will then traverse to the next node. Current will now hold the address of 0x300. The node that's being pointed to by temp will be printed. So in this case, index 1 will be printed with the data of 20. And then on line 74, this node is going to be deleted. And then we go back to line 68 and restart our while loop all over again. Current does not equal null. No, it doesn't. It's holding 0x300, so that is a true statement. And if that's the case, we're going to have temp follow. So we're going to assign the address of current to temp. And then on line 71, we are going to traverse current to the next node. And on line 72, the data that's being pointed to by temp will be printed. So in this case, 30 will be printed and index 2 will be printed. And then after that, on line 74, this node will be popped. And then we go back to our while condition again on line 68. While current does not equal null. Well, it doesn't equal null. It's holding 0,400. So if that's the case, temp will follow current. And then on line 71, we will traverse current to the next node. So current will now hold the address of 0x500. On line 72, the index 3 and data 40 will be printed. And then on line 74, index 3 will be popped or deleted. We go to line 68 again. Does current equal null? No, it doesn't. On line 70, temp will follow. On line 71, we traverse current to the next. Well, let's take a look at the next. The next is null. So current will now be pointing to null. On line 72, we'll print the data of our index 4 with the data 50. And line 74, this will free our node. We go back to line 68. Does current not equal null? Well, current does equal null, so this condition is now false, and so we exit the while loop. And once we exit the while loop, the last thing that we want to do is set our pointers to null, so we don't have dangling pointers. We'll start with head, we'll set that to null, we'll set our temp and current to null, and that should do it. So let's go ahead and test this condition. So I went ahead and uncommented one function call for line 36, so we should have 30 on our list, one node and 30. So let's go ahead and run this. So we have 30, number of nodes 1, before garbage collection, index 0 was deleted. Actually, let me change this to after garbage collection. Okay, let me go ahead and uncomment 2 nodes. So our original linked list, we have index 0, 20, index 1 at 30, and the number of nodes is 2. After the garbage collection, notice how index 0 was deleted, and it's always going to say index 0 because temp is currently following. So whenever the head node gets deleted, the index numbers are shifted to the right. Let me go ahead and uncomment all of them. So before our garbage collection, we had 5 nodes, increments of 10, 10, 20, 30, 40, 50, as you can see right there. After our garbage collection, notice how data 10 was deleted, data 20, 30, 40, and 50 was deleted. So now our heap is clean. And that is our pop list function and how to clean up garbage in the heap, or how to clean up memory in the heap.